Hello everyone. In today's video, we're going to talk about AWS DynamoDB. AWS DynamoDB is one of the most famous offering under the category of NoSQL databases. Previously in our videos, we have spoken about relational type of databases like Aurora, Postgres, and we have seen how to create them using the console. Today we're going to talk about DynamoDB. Before we get started, let us understand why do we need a NoSQL database in picture. I'm sure most of you, when you have started your career, you have worked on any one of the RDBMS database like Microsoft SQL, Oracle, Postgres. There are many databases like DB2. I'm sure all of us might have started our career working in one of these RDBMS database. So these databases were enough for the requirement of previous generation, where the volume of data was not huge, and we mostly use this for OLTP uh, kind of requirement, right? Now, there's another category of database called OLAP. So these databases were used to run reports on top of the traditional RDBMS database. So we used to migrate the data from RDBMS to OLAP using one of the ETL tools. And then on top of those data, we used to create reports and analytics, and which is ran on top of the traditional data. So these two databases were very much common in previous generation, or when I say previous, just 10 years back, you can say. But as the advent of internet and internet-based applications and many internet-based social networking sites, RDBMS were not able to handle the huge load of data. So the volume of data was huge in terms of terabytes and petabytes, and RDBMS was not sufficient or not smart enough to handle and process the huge volume of data. So for that, the big data concept came into picture. So in big data, we have a lot of database like HBase, Cassandra, MongoDB. So these big data database were mostly NoSQL, and the biggest benefit of NoSQL database that it could do the operations which your both traditional RDBMS and OLAP based database or data warehousing applications were able to do. So which means they were able to store the information and also run analytics or reports on top of those data. So this was a huge innovation in previous years during the advent of big data. And what we're going to see today in today's topic is one of the NoSQL databases, which is being offered by AWS called DynamoDB. So why NoSQL? Because the nature of data was unpredictable. There was a huge variety of data. The variety of data was no more consistent, which the RDBMS were handling. So when such data started flowing in internet on IoT applications, we need to have a different variety of database to cater the needs. And the volume of semi-structured and unstructured data was also growing in size in terabytes and petabytes. So RDBMS was basically not able to handle unstructured data. So when I say unstructured data, we're talking about data such as JSON or XML or images or videos, right? So RDBMS is not designed to handle such kind of a data load. So that's when the NoSQL database came into picture. These NoSQL database are distributed in architecture, which provides better speed, and they are not as costly as compared to RDBMS. And one of the most important feature is they do not have a fixed schema. If you don't understand what this means, just park your question. We will see that, and we will see that shortly in this video itself. These are some of the advantages. Like you can just Google through, and you'll be able to come across like these are open source. These can be easily replicated, and there are currently over 150 SQL databases in market. I'm sure currently, if I just Google, there should be more than 200 as well. The major benefits of NoSQL is the volume. It's able to handle huge volume of data, velocity of data, and also variety of data. So these three are considered the three V's of big data world. If you look at any textbook, you will come across these three V's. I think now currently they're talking about 5 V's or 6 V's, I'm not sure. But until few years back, were these three V's were considered as a reason to migrate to a big data platform. Now these are the different categories of database which you're seeing. On the left hand side, you have the SQL databases, which is Oracle, your Postgres, your DB2. On the right hand side, you have NoSQL database. So in reality, there are four main types of NoSQL database, starting with your key value, columnar, document based, and graph based. Document based storage is categorized by its ability to store documents made up of tagged elements. If you have looked into MongoDB, then you may be familiar with this type with a column based or column oriented database. With a column-based or column-oriented database like Cassandra or HBase, data is stored and optimized for fast retrieval of a lot of data. This is in contrast to the row-based storage or row-oriented storage of traditional relational databases. With columnar systems, you are able to work and retrieve large datasets because of the column-based retrieval. Where we'll be focusing most in this course, though, is the key value data stores. This is where you'll find systems like Amazon DynamoDB, Memcache, Redis, and lot others. DynamoDB is mostly it falls somewhere in between the document DB and the key value category of database. Another key concept which you have to know before we jump is this CAP theorem. So CAP theorem basically means any NoSQL will fall in any two categories of CAP theorem. So CAP theorem basically means consistency, availability, and partition tolerance. So you won't be able to get all these three in any one database. You have to compromise on any one of it. So if you say that you want a NoSQL which is highly available and which is partition tolerance, then you have to compromise on consistency. If you want something which is highly consistent and partition tolerance, then you may have to compromise a bit on the availability. So if you just see this picture, where does DynamoDB falls? It falls under this category of A and P, which means DynamoDB is highly available and partition tolerant, but you may have to compromise a bit on the consistency. So consistency basically means whenever you query a database, you should always get the consistent result. You should not get any stale data. A partition tolerance means that if you have four different servers, if any one server goes down, still your consumer should be able to access the database. Availability means your database should always be on. So these are the three pillars of CAP theorem. Now, even though DynamoDB says that it has to compromise on the consistency, let us see how AWS solves this issue. So coming back to a slide, DynamoDB is a fully managed NoSQL offering by AWS. It is a serverless, key value and document based database. DynamoDB is able to handle up to 10 trillion requests per day and supports peak of more than 20 million requests per second. So if you look at these numbers, do you think a traditional RDBMS will be able to process at this rate? It's almost impossible. So for that, you need to have something like a DynamoDB to give you results. It is used by applications which require millisecond read latency. So before we go any further, I just want you to share some of the blogs which is given by AWS. So let me quickly open my browser. So this is one of the blogs by AWS. So it says that on Amazon Prime Day on 2019, there was a huge surge of requests. And if you look at the Amazon compute infrastructure, they have basically given how with the help of a DynamoDB, they were able to cater like they were able to process 63 petabytes of storage ahead of Prime Day. The resulting fleet handled 2.1 trillion requests per day and transferred 185 petabytes of data per day. So this is with help of Amazon DynamoDB. So these numbers are just thrilling, right? So you're seeing numbers in terms of petabytes and terabytes and trillion requests per day. You can't even imagine processing such huge requests in a traditional RDBMS. And there's another interesting blog of AWS where they have clearly documented how they were able to save a lot of money after migrating their infrastructure from Oracle databases to the AWS managed databases like DynamoDB or Aurora instance for that matter. So what they have said is the cost reduction were reduced up to 60% on top of heavily discounted rate, and the customers regularly report cost savings of 90% by switching from Oracle to AWS. And if you look at the performance, the latency of our consumer facing applications was reduced by 40%, and also the administrative overhead were reduced up to 70%. So these are some exhilarating and thrilling numbers. Although AWS have not said how did they arrive to these numbers, but I'm sure these numbers might influence you to migrate your database from Oracle to AWS managed databases like Aurora or DynamoDB for that matter. Now let us see some of the key concepts in DynamoDB. DynamoDB, we have something called item and attributes. Just like how in our DBMS you have rows and columns, so here we call them as items and attributes. So every row which you see in a DynamoDB is called as an item, and an item can have any number of attributes in it. So since this is schemaless, each item can have different attributes or the same attributes. It doesn't matter. And we can set a time to leave period. So after the time to leave period, the item will be automatically deleted from the database, or you can archive it to an S3 bucket through AWS Lambda. Now when we talk about primary key, this is some of the common concepts in both RDBMS and DynamoDB. So here primary key is used differently. So the primary key is basically a combination of two keys. One is a partition key and another is sort key. Now here sort key is optional. If you want, you can use a sort key, or you can just use a partition key as a primary key for your table. Now what is a partition key? Let me open my dashboard and clear all these. Alright, so as we know that our DynamoDB is partitioned across multiple servers. Let us say you have different servers, server 1, server 2 and server 3. So whenever you store any data in your DynamoDB, it will be stored across these three different servers. So how will DynamoDB decide on which server to store this particular item? So that is where partition key plays an important role. Say for example, I'm trying to save my employee database, and I'm saying that my employee ID will act as a partition key. So I can, if I want, I can also have another case of sort key. I can say department as a sort key, but it's totally optional. So when I say, so we will not bother about sort key for now, but when I say employee ID as a partition key, so whenever you store a particular item, it will send different items in different servers based on the hashing algorithms on the employee ID. So say for example, you have a function which takes employee ID as an argument, right? And based on the value, it will decide on which server this particular column has to get stored. So all the employee IDs of which starts with 1 can be saved in this server. All the employee IDs which starts with 2 can be saved in this, and all the employee ID which starts with 3 can be saved in this. This is just a rough example, but when you set a particular column as a partition key, then that is a mandatory attribute, and based on that attribute, the DynamoDB will decide on which server to save your data. So now why are we doing this? We are doing this because when you query your DynamoDB based on a partition key, it doesn't have to scan across all the servers. It will basically store a metadata information which will say, okay, partition this particular partition key is saved in this server, so the DynamoDB will directly go to this server and retrieve the data for you. So the data processing speed is increased drastically. You just compare, like, instead of how much time can you save instead of scanning across all the servers and just scanning across one server. So this is like a library, right? So in library you have different books. you have partition. Okay, this shelves you'll have only science and technology book, and in other shelf you'll have all the fiction books. So when you go searching for a book, you don't have to scan across each and every shelf in the library. You can just go to the particular shelf where the science and technology books are stored, and you can search the book. It will save your time drastically. That's the same concept applied here in DynamoDB as well. So this is where your partition key plays a very important role. Now let us go back to a slide. Now these are some of the parallels which drawn between a traditional SQL database and DynamoDB. A table is called as table here as well. A row is called as an item. A columns are called as an attribute. Now one of the basic difference in traditional RDBM is the columns are fixed. So whenever you create a table, you have to create a table, you have to create the columns along with your tables. You cannot create just a table, you have to create your columns along with your table. Whereas when it comes to DynamoDB, you do not have to create your attributes. You just have to create a table, and then you can add, whenever you're adding an insert statement, you can add any number of attributes. No two rows need to have the same attributes. So when I say row in DynamoDB, we'll be calling them as item. So no two item can have the same attributes. They can have completely different attributes as well. So there is no restriction by DynamoDB. That is why we call NoSQL database as schema-less database. They don't have a schema, right? And we have the same concept as primary key, but here the primary key is used for different purpose. This is used for partitioning. And then we have secondary indexes, where if you want to add some other frequently accessed attributes is being searched, then you can set that particular attribute as a secondary index. That will also help in querying faster query results of your queries. And then there is something called read consistency. So read consistency basically means, so you have to remember the CAP theorem when we talk about consistency here. So CAP theorem basically means you have availability, consistency, partition tolerance, and your database will fall in any of two categories. You will not get all the three in one single database. So as we have discussed earlier, DynamoDB falls under availability and partition tolerance, which means the consistency has to be compromised. So this is what we discussed earlier. So what does it actually mean? Let me draw a diagram for you. Let us say you have different servers. One server is used for write operations, another server is used for read operations. Okay, this is basically used to increase your write and read throughput. So let us assume that your server number 1 is used for write operation and your server number 2 is used for read operation. So when I update a particular attribute of an item, so say for example I'm saving the employee details as an item and I'm changing the age from 35 to 40. So when I'm updating the age of a particular item, this data will be synced, right? From this server to this server, the data will be synced, and from server number 2 to server number 3, it will be synced. So this happens on eventual consistency model. So when I query a particular item, so the read request will be read from server number 2. Now even before the databases are synced, if I try to query, then I will get what will I get the age as? I will get the age as 35. So this is a stale data. So even though I have ran an update operation, I have changed the age from 35 to 40, and the very next millisecond if I'm hitting a get operation, there are possibility that I might get a stale data as 35. This might happen if I run a read operation while the data has been synced or just before the data syncing has started. But if I try to hit the same query after a few seconds, I might get the updated value as 40. But there might be a scenario where DynamoDB might return me a stale data. So this is common across all the NoSQL database category, which falls across A and P category of that pyramid. So whichever falls under A and P, they may have to compromise on the consistency. So they all falls under, this is called eventual consistency model, which means the data will be consistent eventually, not immediately. So let us go back to the slide and see what AWS says about this. So AWS says the DynamoDB supports both eventual consistent read and strongly consistent read. So strongly consistent read means at any given point of time, you will always get the latest value and there is no chance you will get the stale output. How does it do that? Whenever you hit a read operation, it scans across all the servers, it checks whether this is the updated value and then return back to the customer. This obviously will have some performance impact. But if you're not ready to compromise on the performance, then you can go for eventual consistency read. So not always you will get stale data, but there is a risk where you get a stale data. So this is what AWS talks about DynamoDB. So you can make your DynamoDB highly consistent, but that will come under some performance impact. Next comes is the throughput. So by default, when you create a table, you have to set the throughput as read capacity unit and write capacity unit. If you don't set it, by default the read capacity unit is 5 and the write capacity unit is 5. Now what does this read capacity unit means? It means that one read capacity unit represents one strongly consistent read per second for an item up to 4 KB in size. So let me open a notepad. So one read capacity unit means, now we have seen 4 kilobyte of data, 4 KB of data. So 5, when I said the default is 5 RCU, right? So when I say 5 RCU, that means it can give up to 5 into 4, which is 20 KB of throughput. So this is in the case of strongly consistent read. So which means you always need a consistent output. But if you're able to compromise on the consistency, then this output can be doubled, where you will get up to, so when we double this, how much you will get? 40 kilobyte of throughput. This is in case of eventual consistency model. This is the read capacity unit. Now write capacity unit says that one write capacity unit is equal to 1 KB of write operation. So when I say 5 write capacity units, it's obviously it's 5 into 1. You will be able to write 5 KB of data per second. So this is all per second. So let me write this per second, and this is also per second. So whenever you create your table, you have to specify what will be the read capacity unit and write capacity unit based on the requirements. So you'll have a fairly understanding on how your application has to perform and what kind of a throughput your application should be able to handle. So based on that, you have to set your read capacity and write capacity units. And based on this, your application will be auto scaled to handle this particular requirement. So there are two types of thing. One is on demand and provision. So when you give this particular, when you set provisioned as a option, then you have to specify the read capacity and write capacity units beforehand, and your application will be scaled accordingly. Or if you select on demand, then you do not have to specify anything. You do not have to specify the auto scaling concept. It will be scaled based on the demand of that particular minute. So as and when your application gets huge load, it will be scaled up and down automatically. But as it also comes up with a huge cost. So it's up to you whether you want to set up provisioned model or on demand model when you're setting your database or when you're setting your table. Okay, so we have seen enough of theory. So let us go back to our AWS console and try to create some database for you. So this is the AWS console. Click on services and type Dynamo. So you should be able to see the DynamoDB. Click on this. So you will be seeing the dashboard of DynamoDB. So create table button. Click on this, and then this is the template which you have to fill to create your Dynamo table. So let me give some name here. Let me say songs or music. I'll call it as music. And then the primary key will be the, so we have to decide on how we want to partition our table on based on which key, right? So this will hugely change the way we query our database. And this is also related to the performance. So let me see that my music database will have artist name and genre of music, and it could also have the song name. So I'll partition based on the artist name. Okay, and let me add another sort key, which is genre, and I'll keep both these as string. Now if this table settings, if I use default settings, then it will create with the default settings like no secondary index, and provision capacity will be 5 reads and 5 writes, and no encryption. But if I want to change, let me uncheck this, and here I can add some of the some of the secondary indexes, and I can change the read capacity units and write capacity units, and I can also change whether I want to whether I want to stay with provision mode or on demand mode, right? So we have discussed all these things in our in our slides. So auto scaling is basically how much to upscale and downscale my application, right? So it can go up to a minimum of 5 units, and it can go up to 40,000 units when the target utilization is 70%. So similarly for write capacity units, we can either have a different settings, or I can just say use the same settings as read. So for now, for this demo, I won't be changing any of these options. So let me create a table with default options itself. So I just clicked on create table, and the table is being created. I think it is still in process. So as you can see, the table has been created with the name of music, and on the right hand side you can see a lot of tabs. We won't be seeing on all those tabs in this video. We will slowly discuss this in our next videos, but some of the key things which you have to know is in the overview section, if I come down, it gives you a basic overview on how this table has been created, what is a partition key, what is a sort key, and is there any encryption, and when it was created, what is the table status, what is the read capacity and write capacity units. And there's something called manage TTL. So manage TTL is I can give that attribute name. Maybe the attribute name could be the date time or creation date or something like that, and I can give when this particular item has to be deleted from the database, right? So if I want to delete the database, I just have to set uh, the date on which the data has to be deleted. So suppose I'm saying on the same date, and I'm just saying 25. Okay, and the attribute date as date, I'll just give it as a date. Okay, so whenever I insert a new item, and that particular item will be deleted once this particular time has been crossed. And I can also enable this, so which means that after this items has been expired, if I have to uh, archive this particular item in S3 bucket or any other medium. All right, and items, click on items, and here in items click on create item. So the artist name is default and genre is default because we have set this as the partition key and the sort key. So the artist name I'll give as Eminem, and the genre I'll give us rap. Let me add a new attribute. Let me say something called age. Age I'll set it to 32, and then I can say what is a label. Oops, no, I need to have a string. Okay, what is the label? And this is under, I don't know any foreign labels, so let me just give ABC and click on save. So as you can see, first item has 4 attributes: artist name, genre, age, and label. So let me create another item. So the artist name will be Ed Sheeran, genre would be blues. Let me add another label, and it could be GEF. And here I'm introducing a new attribute. So this new attribute is called, what will it call as, I could say country, and I would say India. Okay, so this is a new attribute I'm introducing right now, but still the DynamoDB does not complain. It is just able to accept it, and on the fly, on the runtime, whenever I introduce a new attribute on each insert item, it will just accept it. So I can have a different schema for each item, no matter, it doesn't complain as in case of RDBMS. In RDBMS, this is completely impossible. It follows a strict schema. So whenever I insert a particular query, I need to follow the column names. I can't introduce a new column on the fly. But in terms of NoSQL, that's the biggest advantage. Each item can have a different attributes. It can have a completely different attributes, or it can have the same attributes. It doesn't matter at all. So that's why we say in unstructured data. So this is the example of unstructured data. It does not have a fixed structure. So in case of unstructured or semi-structured data, NoSQL is the best fit for you compared to RDBMS. So these are some of the query. So if I want to query this, let me select query, and here I have to select a partition key. So the partition key would be artist name. So I will say Eminem. So Eminem can sing many songs, right? So this is just one record. So under Eminem, I can insert hundreds of uh, items in that case. So when I say start search, it will give that particular record. Or if I want to search to another attribute, say for example, I want to search based on the age. I want all the songs which is sung by an artist whose age is less than 50. Okay, so this will give me nothing. Okay, age is what, a number, so it gives me Eminem. So the difference between scan and query is that when I give query, I need to specify the partition key as well. So the DynamoDB will know on which particular server that this particular record has been stored, and it will directly go to that server and fetch the record for me. Whereas if I give the scan, I'm not actually giving the partition key here. So the DynamoDB will not know on which server does this record exist. So it will basically scan the entire cluster of servers, and then it will give me the result. So especially when you're having a data of huge size in petabytes and terabytes, scanning will take a lot of time. Whereas if I go to query, it will be able to process the record in shorter time. So that is a difference between um, a scan and a query. So let me remove this. Okay guys, so this is the basic example of how to create a table and how to use scanning and query. And there is another thing which I want to discuss is global tables. So what is a global table? Global table basically means having you're creating a table in multiple regions and which is fully managed. So by default, we have created this table music in North Virginia region. But if you have a lot of customers in Asia, then it is always a good idea for you to create a replica of this table in one of the Asian regions. So how do you do that? You have to enable streams for this, and then the add region button will be enabled. So click on add region and select the region where you have to create a replica. So since I'm in India, I will select Mumbai, and then it says region is ready. Click create to replica. This proceed. So when I click on create replica, it will create a replica of this particular table in Mumbai region. So whenever any customers from Asia is trying to hit, they will be accessing the Mumbai region database, and any customers in US will be taken to the database hosted in North Virginia region. So this is the overall concept of global database. So this will basically enable to use DynamoDB as a fully managed multi-region, multi-master database. So whenever you have a requirement of creating, you have a pan global audience and you want to uh, give a higher throughput for all the customers across all the globe, so you can create a replica in different regions, and then you can it will be easier for the customers of that particular region to hit the database hosted in the region which is near to them. So this is the overall picture of DynamoDB. So in today's video, we have spoken about what is NoSQL, what is DynamoDB, and we have also spoken about we have also seen a demo on how to create a table using AWS console. In our next videos, we'll be seeing how to basically query the records using different APIs and different IDs. I will be talking a bit more about the indexes, the security around the DynamoDB. So let us restrict whatever we have spoken till now in our today's video. So guys, if you have liked this video in DynamoDB, please don't forget to like and subscribe our channel. If you subscribe our channel, you'll be able to get more such videos from AWS and other fields of technology, and you'll be able to learn a lot of things. If you want me to talk about a specific topic, please comment it out in the section. I will definitely make a video on the topic as well. Until then, goodbye and thank you for watching my video.